Alright guys, so I'm in the middle of forge weld test run with my gas forge. If you see, I got it blocked off in the front, I got it blocked off in the back. I'm doing some mild set. I have 3 like small mild steel pieces together that I've so far forge weld successfully. Now my flux is this 20 milliliter borax detergent stuff. Now there's a lot of moisture in this, so you got to use a lot of it, but it's really, really cheap. And this is really good. This is a really good start out flux because it's more difficult to use this than it is the purpose stuff, but it achieves the same thing. You just got to use more of it because of the moisture. But yeah, so I guess in ancient times they'd use like, you know, like paper and beeswax or sand, but we have this, so that's what we're using. Okay. Okay, now I'm going to take the piece out of the forge and show you what it looks like. There we go. Now this is one homogeneous piece. This was 3 smaller pieces when I started out in. So what you got to do is you got to clean your pieces up, and then you got to stack them, make sure they're as even as possible. And then I just tack weld one tack on the front, one tack on the back, and one tack on each side. Now I have some more forging to do because, you know, like the ends are split a little bit here on this side. I closed this end earlier, you know, and squeezed it all out. I'm going to end up upsetting this piece and then, you know, making it in one piece. And I'll be able to use this for something else because I don't have this crappy little small piece that I don't know what to do with. And I'm just trying to recycle what I got. So I'll find some other pieces that are about the same size, and then eventually I'll be able to use this for something or make something out of it. But yeah, now the gas forge doesn't quite get up to the temperature that you would need, like on a coal forge. Like you can't just take 2 separate pieces, lay them on the anvil here, and then squash them down, and then, you know, more or less it just kind of does a light bond. The gas forge doesn't quite get up that high. I think it has a lot to do with my centrifuge design that I got on this one. But it works good enough. I can do compression welds. I just have to make sure my surfaces are really clean, and then I got to tack them together so they can't move around. And remember, you can't just wail on it when you're doing a compression weld, because that's what we're doing. You want nice controlled strikes when you come down, just like 1, 2 on the thing, and then off, because you're trying to drive the force down in there, not just, you know, just blast it away. The way the molecules work is if you try obliterating the place, what happens is that the electrons scatter. They don't want to circle the other atom, because that's what happens when you have similar atoms. Iron atoms lock in together. Their electrons will share their electrons. They jump from one atom to the next. So, but it's a perfect trade-off. And in order to have that material all in one homogeneous piece, they have to get that equal trade-off. So you can't just obliterate your piece with this giant hit. So good, strong downforce hits, but nothing. You're not trying to obliterate. You're trying to compress the material together. So that's the secret as far as that goes when you're doing it by hand. Can you make a small piece of Damascus? Yes. Would you really want to? It's very time consuming. You're going to use a lot of gas. I mean, you could do it, but you wouldn't want to do anything bigger than what you would need for a knife, though. I mean, if you're going to do a sword, you're talking about, you're talking about, 2-3 months of just by yourself hammering. And you can use the same thing. You can just heat it up in sections, and you'd be able to do it. You can make a sword that way, but it takes a very long time. I mean, they did that, the Viking Sax sword, that's why they did it. They did the high carbon and the low carbon material, and they squashed it, twisted it, bent it together, and then after that punched it, it gave the both the best worlds because of the carving difference between the materials. But there you go, forge welding. I probably have another small pieces I'd like to add to this, but it came out really good. It's all one homogeneous piece now. I was really surprised that I was actually able to do this, but that's pretty much it. Forge welding.